Okay, so this is part 3 of writing equations from our linear packet. All right, so let's start about here. All right, it says at a restaurant, jars of tomato sauce are stored in boxes in the pantry. Each box contains 8 jars of tomato sauce. A cook uses 2 jars from one of the boxes. Which function shows the relationship between y, the total number of jars of tomato sauce remaining in the pantry, and x, the number of boxes in the pantry? So, x is the number of boxes in the pantry. We don't know what they are, so that's why we're writing x. So, the number of boxes in the pantry, right? How many jars of tomato sauce is in those boxes? Well, 8. So 8 jars per box. Per is the times, box is the x. So that's where we're getting this whole 8x idea from. So that means D is out of the question, right? Okay, it says a cook uses 2 jars from one box, right? So we subtract 2 because that's been used. And our answer is C. So this whole each times box is x. So the number can't be too far from it, and it's not. It's right here. So that's how we know it's 8x. Then it said the cook uses 2 jars, so that's minus 2. All right. Researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. Which function can be used to find the thickness of the ice shelf in meters? X days, so we're looking for the thickness, X days since the discovery. All right, so we want Y. All right, we want Y. So basically, write a function. It tells us a couple of things that we should note. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day, right? All right, this whole decreasing minus the 0.06 meters per day, right, times x. So the number in front of that multiplication is 0.06. So that's how we know our first leg is y equals negative 0.06x. Now, when we first started, the thickness was 450 meters when it was first discovered. Can't worry about how thick it was before then. It does not matter. So we're going to add 450. All right. Another way of writing this could be y equals, we put the 450 first, right? Minus 0.06x. These represent the same thing. Okay. They're the same thing. Leaving us an answer of A. Here it says which equation describes the line passing through the points 3, 0 and 0, 4. There are a couple of ways we could look at this. We can go to our calculator and go to Stat, Edit, and plug in for X for our L1, 3, and then 0. And then for L2, type in our y's, which is 0, 4. And then to come up with our equation, we press stat. We go to calc. So we go over to calc. And we press 4. And then enter. And it tells us that our A is negative 1.3 and our B is 4. So our equation is y equals negative 1.33 repeating plus 4. Oh, x plus 4. Well, what can we say about this? It's not if. But how do we determine the rest? So there's a way for us to plug in H and J in the calculator. If we go to this y equals here, all right, notice how we start with our C, right? We subtract our AX and we divide by our B. So what's our C in this situation, right? Because this is standard form, right? Our C is 12. Our AX is 3x, right? Put that in parentheses. Press the division symbol and divide it by our B, which is 4. If we plug that into y1, we're going to get a graph that represents this. If you can remember this right here, then you can put any standard form into calculate 84 or TI 84. So again, parentheses, 12 minus 3x, close parentheses, divided by 4. We're going to press graph. And what we're looking for is our x and y intercept, essentially, are these points on the graph. Well, let's see. All right, if we press trace, all right, if we notice this point, the blue point, is 0.03. And what we want is 0.4 for the y-intercept. So this equation can't be it. We're going to cross that out. So now let's put in the last one. All right. We're going to try this one now. So our C is 12, our AX is 4x, and our B is 3. Let's plug that into y equals. All right. So that's 12 minus 4. Okay. Let's try that again. 12. Parentheses. 12 minus 4x, close parentheses, divided by 3. All right, now let's try it. All right, if we press trace, notice how we're starting. Let's see, let's press that again. Trace. All right, great. Notice how we're starting. It says x is 0.02 and y is 3.973. All right, we can confirm that by pressing 0, enter. And if you just press 0, enter, it's going to tell you for 0, y is 4. What that means is that's a point on the line. So we're already getting started because 0, 4 is what we want, the equation that goes through that point. But we do need to check to make sure 30 is on this line. So press trace, and then we're going to click the right arrow. Let's see. All right, there we are. That black dot is on the x-axis, and x is 3 when y1 is 0. So we know that this point is also on the line. So our answer is J. All right, for the next question, it says, which function represents the same relationship that's in this graph, or table rather? So we're going to go to our stat, edit, and notice how these are already filled in. If you come up and press clear, okay, or not. Let's see. Let's try that again. 1. All right, you should be able to press clear. When you go to L1, come back down, and then all the values disappear. However, this is calculate and not TI-84 or 83. So I think I'm going to have to do something a little different. So we're going to come here and press delete. And delete works here. All right. A lot better than I thought it would. All right. So we're done with that. Now we're going to put our x values in this problem into L1. So negative 7.5, negative 3.5, negative, negative 1, two, 3.5. All right, and then we're going to plug in 12, 0, negative 7.5, negative 16.5, and negative 21. All right, we press stat, go over to calculate, and press 4 and enter. Notice how we're given our A is negative 3, so that's y equals negative 3x minus 10.5, because that's our B. And the equation that represents this is A. All right. For the next one, the scatter plot shows the monthly high temperatures for Austin, Texas in degrees Fahrenheit over a 12-month period. Which function best models the data from month 1 to month 9? All right, so what we can do is draw a line that ends about at month 9. So we're going to do the best we can. We're not trying to be perfect here. We're just trying to get the point. So if we start here, and we're drawing a line through the middle of our data. All right. The question says, which function best models the data? Well, one thing's for sure, this line is increasing from month 1 to month 9. So anything with a negative slope, we want to eliminate. So that's F and J. And then from here, we need to look at our y-intercept. The y-intercept is right about here at 89, which is closer to 90. So we're going to choose the answer remaining that has a y-intercept of 90. And there we are. A zookeeper recorded the feeding schedule for baby rhinos for 20 weeks. The table and scatter plot show the percentage of the baby rhinos, rhinoceroses, or rhinos, body mass that was used to determine the amount of food given at each feeding as a linear function of its age in weeks. All right, so age is going to be our X, percentage of body mass, Y. All right. The question is, what is the best prediction of the percentage of baby rhinos' body mass that should be used to determine the amount of food given at each feeding when it is 25 weeks? So basically, what happens when X is 25? What's Y? That's the question. All right, that's the question. All right, the recommendation is that we come over here to our calculator, go to Stat, Edit. Remember, for those of you that are using TI-84s, you can come up here to L2, click Clear, come back down, and the list will be clear. Do not click Delete. All right, those that are in the app, we can just press, come here to each value and press Delete, and it goes away. All right. So in L1, we're putting our X, so that's 1, 2, 4, 7, 9, 12, 14, 15, 17, 20. All right. And then for L2, we have 20, 19.5, 17, 15, 14, 13.5, 12.4, 11.6, 11, 9. All right, and now we're going to go to Stat, Calc, 4. Enter. All right, and notice down here we're given y is equal to negative 0.54x plus 19.8. We're going to plug in for this x, that 25 weeks, so that it's negative 0.54 times 25 plus 19.8. And that's 6.3. So there we are. All right, and then we're going to go through the same process here. All right, we're going to plug in age X, Y is the height, and we're going to come up with an equation here. All right, and we do the same step. All right, you're going to do the same step here, and when it says what does the correlation coefficient for the data say, you're going to look at the scatter plot here and determine the straight. How much of a straight line is it in, or is it more of a scattered line? And determine whether it's a weak negative, strong negative, weak positive, or what.